rule number 4 now. To each repeated linear factor in the denominator of the form x minus a all raised to power 2, there corresponds a partial fraction of the form a over x minus a plus b over x minus a all squared. For instance now, let's say we have a fraction 2x over x plus 1 all raised to power 2. Now, this denominator is a repeated linear factor, and that's because it has raised to power 2 to it. If I must separate this into its partial fraction, it will take the form a over x plus 1 all squared, x plus 1 without the square first, and then plus b all over x plus 1 all squared. That's what this rule number 4 is trying to say. Let's say we have on that one now, for instance, 1 minus 2x all over x minus 2 all raised to power 3. To separate this into its partial fraction, it will take the form a over x minus 2 plus b all over x minus 2 all squared plus c all over x minus 2 all raised to power 3. And this is the form it would take. Now let's take some examples under this now. Example 6. Resolve into partial fraction 7 minus 2x over x plus 1 into bracket x minus 2 all squared. Well, the first thing to always do is to always check for your rule number 1 first. Obviously, because the degree of the denominator is greater than the degree of the numerator, we don't need to divide here. So that is skipped. And as I look at this now, the first thing to do, I'm seeing the linear factor there. We will write it as a all over x plus 1. And then again, I'm seeing a repeated linear factor. Remember, how do we do this? It will be b over x minus 2 first plus c over x minus 2 all squared. Yes, because of the rule number 4. And now we find our LCM. Please take note. Our LCM here is x plus 1, x minus 2 all squared. Please don't write your LCM as x plus 1, x minus 2, and x minus 2 all squared. That would be wrong, because in this you can find this inside of it. Yes, if you want to do your LCM, you can simply say, let's just do that fastly here. Our LCM, actually, we have x plus 1, and then we have x minus 2, and then we have x minus 2 all squared. And if you are looking for your LCM, you look for what can a factor. X plus 1 is a factor, and if it goes there, it gives to give us 1. This will still remain x minus 2, and this will still remain x minus 2 all squared. Now the next factor to use is x minus 2 now. If you use x minus 2, this is already 1, but this will give us 1, and this will give us x minus 2 now, because only 1 will be eliminated because it has a power of 2. Now you have to use x minus 2 again, and that will give us 1, 1, and 1. So you can see now, what's our LCM? Our LCM is x plus 1 multiplied by x minus 2 multiplied by x minus 2, and that will give us x plus 1 into bracket x minus 2 all squared. That's what we have here. So please take note of that. I just briefly did that so that you can be clear about the LCM of that partial fraction. Now, having done that, we then combine the fractions now. X plus 1 goes through the denominator, give us x minus 2 all squared multiplied by a. That will be a into bracket x minus 2 all squared. Then plus, again, x minus 2 goes through the denominator, will give us x plus 1, x minus 2 times b. And that will give us b into x plus 1, x minus 2. And then we have plus x minus 2 all squares go through the denominator, will give us x plus 1 multiplied by c. That is c multiplied by x plus 1. So this is what we have. And on the left hand side, we still have our question written. So we have this completely as. The next thing to do is to say, you can see that we have common denominators. So I will eliminate the common denominators now. When eliminated, we then have so from here now, let's solve by substituting now. We take a linear factor we can see here. One of the linear factors we can see is x minus 2. And then we equate it to 0. So we have x being equal to 2. And so we say let x be equal to 2. If we substitute 2 into this equation here we will have what we have here. And so our final answer will be C equal to 1. Again, we pick another linear factor we can see there now. Another one we can see is x plus 1. And we equate it to 0. At the end of the day, x will be equal to minus 1. And so we would have substitute x minus 1 into the equation. And if we do, we have, so we've gotten our a to be 1. The next thing to do, because there's no linear factor again here, we assume any value for x. So we say let x be equal to 0 now. And if s is equal to 0, we would have, so we've gotten our b to be minus 1 now. So hence, we have a to be 1, b to be minus 1, and c to be 1. We can substitute that into the fraction and get our final answer. So our final answer will be as written below. So let's take another example now. Example 7. Now look at this question now. We have resolved into partial fraction x cubed minus x squared minus 3x plus 5 all over x minus 1 into bracket x squared minus 1. The first thing to ask ourselves, subject it to rule number 1 first. Are we going to divide? That's the first question. Are we going to divide? Obviously, we need to divide here because if I expand the denominator, I will have x cubed minus x squared plus minus x plus 1. And then the degree of the numerator is also raised to power 3. So we briefly divide. To solve this, we divide after subjecting to rule number 1. So we would have what look like this now. S cubed minus x squared minus 3x plus 5. And we're dividing it with x cubed minus x squared minus x plus 1. As usual now, s cubed goes in s cubed will give us 1. And then 1 multiplying everything at the divisor, everything here. We would have s cubed minus x squared minus x plus 1. And then the next thing we do is to subtract. So I'm subtracting now. S cubed minus s cubed will give me 0. Minus x squared plus x squared, that's minus x squared, that is plus. We also have 0 as well. And minus 3x minus x will give us minus 2x. And then 5 minus 1 will give us plus 4. So this is what we would have. Hence, this question cannot be expressed as. So this is how the question will be written as. Now, we will now resolve this part into partial fraction because it is one is not a fraction, but this part is a fraction. That's what we resolve into partial fraction. So let's resolve that into partial fraction now. Now, I want to say that the denominator can be factorized. Take note. So we have one that look like this now. X minus 1 first. And then the x squared minus 1 here can be x plus 1 and x minus 1. Yes. Now, if we go ahead to say a over s minus 1 plus b over s plus 1 plus c over s minus 1, we will be wrong. Because we are supposed to have a repeated linear factor. You can see s minus 1 here. You can as well see s minus 1 here. So this will be written as 4 minus 2x all over, there is x minus 1 all raised to power 2 because the x minus 1 is occurring twice then before having x plus 1. So this is what we will have. Then we can now go ahead to resolve into a partial fraction. And so we have a over x minus 1 plus, because it's a repeated linear factor, b over x minus 1 all squared, then plus c now over x plus 1. And as usual, we take our SCM now. Don't forget, our SCM will be x minus 1 all squared x plus 1. And if x minus 1 goes through the denominator, we have x minus 1 multiply x plus 1 times a. That will be a x minus 1 x plus 1 plus, if x minus 1 also goes to the denominator, we have b multiplying x plus 1 plus, if x plus 1 goes to the denominator, we have c into brackets x minus 1 all squared. And on the left hand side, we would as well have the 4 minus 2x x minus 1 all squared x plus 1. So we have common denominators here, so we eliminate this, will eliminate this. Afterward, we will now have, we will then take any linear factor we can see and equate to 0. So we have x minus 1 of the linear factor we can see, we equate to 0. We have that x is equal to 1. So we say let x be equal to 1. If we do that, we would have, and so we have another linear factor again, because we've gotten our b to be 1 now. So another linear factor we can see there is s plus 1. And when we equate s plus 1 to 0, we have x being equal to minus 1. And so if that happens, we have 4 minus 2 into minus 1 being equal to, substituting 1 again, we would have, so putting x as minus 1 into the right hand side will give us what we have now. And then further simplifying will give us c to be 3 over 2. And then, since there's no other linear factor we've not used, we say let x be equal to any other number. Let's use 0 because 0 has not been used. Let s equal to 0. And if we put s as 0, we would have, so this is what my a will give us when we substitute s equal to 0. When we substitute s equal to 0, we have a equal to minus 3 over 2. And then our final answer will be of like this now. Let's write our final answer now. So we take the following exercises now.